Welcome to the Eduonics Cloud course. Now, we are moving on to the topic Introduction to Virtualization. And in today's lecture, we are looking at Virtualization Architecture. This is a document with the title Introduction to Virtualization, and you can find this document in the documentation folder for this topic. Today, we are going to look closely at virtualization architecture. Now, firstly, we'll just go over what is meant by the concept virtualization. So, when we have a real physical machine, if we emulate that real physical machine in software, then that becomes a virtual machine. The actual ecosystem of virtual machines can be sometimes described in cloud semantics as virtualization. It all came about because of the development of a critical piece of software known as the hypervisor. A hypervisor, or as it is sometimes called, a virtual machine monitor, is a piece of software, or it can exist in firmware, or even be created in hardware that creates and runs virtual machines. Now, if you have ever used a disk partitioning tool to divide up your hard disk into logical drives and then install different operating systems on those different logical drives, then you understand exactly what we mean when we say hardware partitioning. Now, hardware partitioning can be a complicated, time-consuming process, and a hypervisor makes it very easy. For the big clouds and clusters, the hypervisor will run like a server, and there will be external software that you can hook into the hypervisor as it supports the virtual machines in real time. So you can look at where the problems are as they arise, and monitor the health of the system that is supporting your virtual machines. So hypervisor is a big step up from hardware partitioning. So now let's move on and review the architecture of virtual machines, focusing on the role of the hypervisor. This diagram shows the two models that we find in the cloud for virtual machines today. First, we have the traditional model, which uses an operating system kernel. Then we have a new emerging model that we find in the topic Cloud Operating System. And this emerging model eliminates the operating system kernel, and that represents a big saving for resources and a big performance boost. The difference is that this machine only runs one application at a time, and requires a language runtime that can run independent of a kernel. Let's go through some of the issues implied by this architecture. So, the first implication is that we have a process, and let's recall the definition of a process. A process defines a container. Inside a process, the resources for that process are not shared with other processes. The process can create its own child process, and those child processes are called threads. And a process can create many threads, and all those threads share resources. That's our simple definition of a process. For our traditional architecture, for virtual machines running in the cloud, we had an operating system with a kernel. This operating system with a kernel can create many processes. So, the virtual machine running in a process has an operating system that can create processes. We have a complication, a doubling up if you like, where in the new model, where we have the language runtime, the virtual machine runs inside a process, but it will not spawn more processes. It can spawn threads, but there will be a single process on this machine. And so this is a simplification, and if you spend any time working development in software engineering, you will understand simplifications like this are big steps forward. So, this is a big step forward for virtual machines in the cloud to eliminate the operating system kernel. And as we mentioned before, the operating system kernel is also a source for security attacks for malicious code injection, and it also works at the hypervisor level, so it is possible that someone can inject some code into your kernel that could penetrate into your hypervisor, and then they will have your whole cluster. So, the emerging model, the cloud operating system model, where we eliminate the kernel, is also a big step forward for security in the cloud. We have reviewed our architecture for virtual machines now. So, we'll move on and we'll look more at the hypervisor and the role of a hypervisor in supporting the stack. For whatever architecture we choose to run to create our virtual machines, we still need to create containers for those machines to run in. One way to make such containers is through what is known as hardware partitioning. There we look at the resources chunks of hardware like a CPU or a motherboard, and we assign those resources to individual containers. This can be good for certain situations, and you may have seen pictures of motherboards where you can run more than one CPU on the motherboard. This allows for a hardware consolidation, but does not give you all the benefits of resource sharing and the fine-grained control by using emulation. And by emulation, we mean creating a virtual resource, and this is offered by hypervisors. Hypervisors then allow us a fine-grained dynamic resource sharing as opposed to the coarse-grained hardware partitioning. Because hypervisors provide the greatest level of flexibility and have virtual resources are defined and managed, they are the primary technology of choice for system virtualization. So they are widely and almost universally used. There are two types of hypervisors. Type 1 hypervisors run directly on the system hardware, and you will find that these, again, are the professional hypervisors used by the big providers. This is our stack for a Type 1 hypervisor. The server hardware layer, a hypervisor layer, and then our virtual machines running our operating systems and applications on top of the hypervisor. This is a stack with the Type 2 hypervisor, and you can see the main difference is that we have an operating system between the server hardware layer and the hypervisor. This server hardware layer could just as easily be your desktop box, and this operating system could be Windows 7, and the hypervisor could be the well-known Vmware or the VirtualBox. VirtualBox and Vmware, where we create virtual machines on our own boxes, are Type 2 hypervisors, and these hypervisors have their advantages, not limited to portability. For instance, we could save our virtual machine to our disk drive, and then we could give that virtual machine to another developer or another person to use and evaluate or work with, and this sort of flexibility provided by Type 2 hypervisors is driving the popularity and emergence of an important virtualization technology known as Docker, which we will go into in a future video segment. So, we have Type 1 and Type 2 hypervisors. The two hypervisors run on host operating systems that provide virtualization services. Now, it's important before you try and run a Type 2 hypervisor that you check your operating system and your CPU provides support for the virtualization technology. Not all CPUs provide virtualization support, and also you need to make sure that virtualization support is enabled in your computer BIOS before it will work. Let's just take a moment now to summarize the key points and look at some important technologies. As you progress in your career as a developer or IT professional, these are the hypervisors and hypervisor-related technologies you will need to know and encounter. Let's say we have the father of them all, the kernel-based virtual machine, commonly referred to as KVM. This is an open-source implementation of a Type 1 hypervisor. That is, it is sometimes referred to as a bare metal hypervisor in the sense that it will run on the hardware. So, I have server hardware, I install KVM on my server hardware, and then I can run virtual machines on that hardware, and I can actually have an external machine which I plug into that server running KVM. Then I can monitor the machines running in that hypervisor. Then we have Red Hat Enterprise Virtualization, which is coming out now in Red Hat Linux version 7. This is a commercial implementation of the open source kernel-based virtual machine, or KVM. So, Red Hat Enterprise Virtualization is a commercial package of KVM. Then we have the dominant player in the hypervisor technology market, Vmware, and they are offering vSphere. This can be as a free version and a commercial package. And these are all Type 1 hypervisors. Microsoft has an important offering, its Hyper-V server, a Type 1 hypervisor, and then the Citrix Zen server is a Type 1 hypervisor. So, these are the key hypervisors of Type 1 which you will encounter in industry and the workplace. Then we have VirtualBox and VMware's Workstation. These two hypervisors we will use as Type 2 hypervisors to create virtual machines on your own box for development and other purposes. They can be important in education and other areas where software emulation is required. To summarize, we find Type 1 hypervisors are the preferred approach. They achieve higher efficiency because they have one less layer than the Type 2 hypervisor. Hardware, the hypervisor, then the virtual machine stack. So, 3 layers: hardware layer, hypervisor layer, virtual machine layer. Whereas Type 2 hypervisors, we have the hardware layer, operating system layer, hypervisor layer, and finally the virtual machine layer. So, the Type 2 hypervisor is less efficient. However, Type 2 hypervisors have their place because they allow you to create virtual machines on your box at home, but they can also be used in other settings, as we saw, such as education, where efficiency is less critical. Now, Type 2 hypervisors also are important on systems where support for a broad range of input-output devices is important. In a very high-end router, you will find Type 2 hypervisors. So, let's move on now and look at some simple examples of working with hypervisors and virtual machines.